Hello there, team, and welcome to an update on our volcano in Iceland. I'm Geology Professor Shawn Willsey. Today is Saturday, April 6th. It's about 1:30 p.m. Mountain Daylight Time here in Idaho. 7:30 p.m. in the evening there over in Iceland. And there's been several days have gone by since my last update. There were some earthquakes I had to deal with and some other things going on. Busy time in the semester. So I don't have quite as much time as I normally would like to for doing some of these updates, but I wanted to circle around and carve out a little bit of time today to update you on some of the interesting situation that's going on there with the volcano, look at some of the data, and then maybe address a couple of questions or some things that have been floating around in the grapevine that Amanda Jo has let me know about. And so maybe I can shed a little bit of insights and help some folks out with some questions they might have. So we are now 3 weeks into this eruption, which began on Saturday, March 16th. And the activity has decreased, but has nonetheless persisted. We are down to one cone or one vent. The activity has shifted from 3 cones down to two this past week, and then I think yesterday or the day before, the cone just to the south of this one went out, and I think even a flight over it with a drone showed that there was no incandescent glow. So that cone and that vent seems to be inactive at the moment. And so we mainly have the largest of the three, this northernmost cone that is the most active, the only active vent left from this eruption. We can see here that it's built up a nice healthy cone. I've got estimates that it's about maybe close to 20 meters tall. Although there's lots of different estimates all over the place, so it's a nice, healthy sized cone. We can see that it has intermittent activity of pulsating lava that's being ejected by gases sticking to the rim. That spatter that just kind of sticks to the rim we call agglutinate. You can see the heavy gas plume coming out of that. And then simultaneously, because this cone is built out of agglutinate or spatter, just chunks of lava with space in between, we can see there is a lava channel being fed at the base of the cone. So earlier in the week, there was a more prominent breach on this side, and the lava was just spilling out. And over the last few days, that has built up into a bit of a bridge over this lava channel. And now today, we can see that that bridge is much thicker, and so the cone walls are a little bit higher on this side than they were previous in the week. And so again, yeah, this lava spatter is quite permeable, and so that lava is just finding the easiest path outward. And for the time being, anyway, it's established a pretty well-developed channel or path out along to the base of the cone here on the southwest side, and that's feeding this smooth lava flow that you can kind of see in the foreground right here. So one of the things that Amanda Jo has told me about, and I want to thank her for always providing me great information and letting me know what's going on. This past week with the Taiwan earthquake and the New York earthquake, that pulled some of my attention away, and I'm just super swamped with, last part of the semester things, field trips, different labs, grading, all those sorts of things. But she said that one sort of thread that kind of had popped up that was many people were discussing was the possibility of part of the wall, the interior wall in the spatter cone, collapsing in and potentially choking the vent. And of course, as we've talked about before, there's two things going on here. As the lava erupts over the rim, as you see right there, that accumulates on the outer slopes and on the flank, and that builds up the height of the cone. And at the same time, all this hot lava moving in the interior actually causes some thermal erosion of that material. So you can see that the inner walls are quite steep and in some places probably even overhanging. And then we have these outer flanks of the spatter cone, which are at the angle of repose for this lava spatter, maybe like a good 40-degree or so angle, 35-degree angle on the outer slopes. So to answer that question, could the interior wall of the spatter cone have a wholesale collapse into the vent and somehow choke this thing off or plug up the hole? The answer to that, I'd say, is no. This material would remelt some of that collapsed material. You might get some disruption of the eruptive behavior and this sort of lava spattering and pulsating intermittent activity that we see here right now. It would definitely disrupt the the eruption dynamics to some degree, but as that material gets remelted and incorporated back, it would likely not disrupt it to any large degree. That would be my take on that. So you'd have to have some other, like maybe an entire flank movement that pinches off some of that conduit there. But the way this thing is structured with this more or less circular vent at the top, and as we've seen collapses take place periodically with this thing, you just see sort of piecemeal collapses, right? You're not going to see like one half of the cone fall into the vent. So just something there that might help a little bit. Another question that's been asked that's out there that Amanda Jo has keyed me in on is looking at why, let's see, the how and why of inflation, why inflation is still occurring during this eruption. So I think we'll spend a little bit of time looking at the GPS data and hopefully answer that. And then a third question she sent to me that was just kind of circulating out there amongst the internet folks was just if inflation continues, if another fissure might open up. And so hopefully I will address those here in a second. But let's start with the Met Office update, and then we'll go through a couple other bits of information as well. The last Met update from the Icelandic Met Office was 2 days ago on April 4th. And we can just scroll through this kind of quickly, but the eruption continues. 2 craters active. Again, that was as of the 4th. That's changed now to 1 crater. The northern crater, the one I just showed you, is larger. Most of the lava flow seems to be erupting from it. The lava continues to flow south from the craters on top of the lava field that formed in the first few days. So again, we have that risk of possible overflows as we sort of build up that southward flow, and that topography is being built up. There is the potential for lava outbreaks off of that perched lava channel to occur and move down slope in any given direction. Some nice pictures here, and then the main thing I want to get to here is this interferogram. Let me read a little bit of the text here first, and then we'll look at the actual image. So the interferogram covers March 18th to April 3rd, shows that land has risen about 3 centimeters around Svartsengi during that time. So remember, our eruption started on March 16th, so this is a comparing 2 time periods, right? They did a flyover with the satellite on March 18th, flew over it again on April 3rd, and it's looking for those changes in elevation of the ground. And this is, again, while the eruption had taken place. So the 3 centimeters rise in elevation, considerably slower than what was measured prior to the eruptions and dike propagations during the last few months. So uplift, but not quite as much as we've seen in the past. Data from GPS measurements during the same period suggests that the rate of land uplift has varied, but it's difficult to estimate day-to-day deformation based on this data. So the GPS is, the trend is so slight there, and the error bars are just big enough that day-to-day it's hard to tell exactly what's going on. We need longer periods of time to see those trends. And we'll see some of those here in a second. But they say that the interferogram and the GPS data seems to be telling the same story. The 2 data sets are consistent. Land uplift is detected in Svartsengi during the eruption, which has not been seen in the events that have occurred previously. So with the prior eruptive events in December and January and February, we did not see uplift happening while the eruption was taking place. Now remember that those eruptions were fairly short-lived. They only lasted at most maybe 4 days, and some of them were only like 1 to 2 days. Nonetheless, this is a little bit different behavior and a different trend than what we've seen in the past. And then finally, this indicates the system is open and magma continues to flow from considerable depth below Svartsengi to the surface in the Sundakur crater row. And so there's your interferogram there. Clearly, you can see the area of uplift just around the power plant. Of course, our eruptions are taking place a few kilometers to the east over in this area, just to the northeast of Grindavik. And so the GPS data and the satellite-based interferogram are both showing, the INSAR data are both showing the same trend. So we can feel very confident then that inflation is indeed taking place despite the fact that we have an eruption still going on. And then they go into a little bit of the gas concentrations and gas measurements and such. But and the gas plume, this was as of last Thursday, I suppose. So let's look at some of that GPS data in more detail. I have a few fun tricks to show you, at least new to me. Maybe I know some of you know about these, but let's start with our typical plot at Svartsengi. and look at this last little trend that we've been paying attention to. So last time I did an update with you, we looked at the initial just slight uplift following the March 18th, 16th, excuse me, eruption. So there's the eruption on March 16th, the beginning of this eruption, and just maybe a hint there of a little bit of uplift. But then that was followed by what appeared to be, during my last update, more or less quiescence, right? It doesn't appear that there's an upward movement at all. But the last few days, there's clearly more of an upward trend in the data. And so, and definitely if you take the average of these first points here, right as the eruption began, and the average of these last points and stick a line to the whole thing, I think you do have a little bit of a slope there and clearly a little bit of uplift. Uplift in the neighborhood of, again, maybe just a few tens of millimeters or a few centimeters, consistent with what the INSAR data showed. So that's pretty interesting. If we look at perhaps the Blue Lagoon data, I think was interesting because it showed that a little more demonstrably. You can see again the slight uptick immediately following the eruption, the more or less plateaued, no uplift trend here in the middle. But then since, I guess, whatever date this is here, maybe, I guess, I don't know, 3, 4, 5 days ago up till today, a much more significant trend upward in the data up until today. So the takeaway here is we've got a good several weeks of data now to look at, and it clearly is showing that there is inflation occurring beneath the power plant region. So that suggests that magma is being stored in the subsurface while at the same time it is erupting. And so that comes back to the question a lot of people have is like, how can we be seeing inflation when there's already an eruption going on? I think the simple answer there is we have more magma coming up from depth and feeding the shallow magma body than we have erupting. And there's several reasons that could justify that. I don't know is the best answer I can give you, but possibly, just as throwing a few ideas out there as we spitball this, as that magma ascends from the deeper source, some of it could be collecting in space that was already created and has been mostly vacated in that magma sill or magma reservoir. So clearly some of it's coming up and collecting there while the rest of it is rising to the surface. We could be looking at some differences in magma buoyancy based on the gas concentration. So as that magma rises, if it reaches the level of neutral buoyancy, it's not going to rise anymore. It's going to stay at that level or that position where it's at. And that sometimes necessitates additional magma with more gas to add more buoyancy to some magma to get that to the surface. So we could be seeing just some little variations in gas flux and buoyancy that could be the small little variable that explains some of this behavior. Again, it could be a plumbing system thing where some of that magma is coming up and going into some other, there could be a split in the pathway, if you think of it that way, like a plumbing system where there's a Y or a V or a T, if you will, and some of that magma is feeding the surface eruption, and some of it's actually collecting in that subsurface chamber and triggering the inflation. So those are just a couple ideas. I'm sure there's plenty others that could be offered as well. So there's just a little bit of the GPS data. I think we see similar trends at some of the other stations there. And I had a viewer, Tim Pointing, sent me an email and keyed me into the fact that you can actually get the GPS data. We've been looking at the GPS data, which only goes back the past 3 months or so. But apparently you can get the data that goes back for a year. And so I'll show you how to get that in a second. So here's our Svartsengi station right here over the past year. So notice the station really comes online this past summer in July. No discernible ground deformation movement. And then as we get into the latter part of October and early November, you can see that trend really kicking up and upwards of 10 centimeters, 100 millimeters of upward movement. Of course, that culminates with the November 10th magma intrusion and the formation of the dike. So then we see everything drop back down as some of the magma from this area is moved off to the east into a different space. And then following that, you can see uplift resuming, and that culminates with the December 18th eruption right here. things deflate back down, continue to rise. There's a little blip right here. That's the January 14th eruption, I would guess. And then we get into February for the February 8th eruption. And then we go into March. There's a little bit of a hiccup there. That was that March 2nd intrusion. And then we get to the March 16th eruption here. But the big takeaway is look at the trend or the slope of these three lines here compared to what we're seeing now. And so while this eruption continues, we may have inflation, and that inflation might go on for quite some time. And we'll have to see if the eruption stops, what happens to the inflation rate. Does it kick up? Does it stay at this level? Who knows for sure, but that will be something interesting to look at moving forward. Other folks have asked me why every time we have an eruption or a magma intrusion event and the deflation occurs, why it's at a higher point each time. And you can see it down here for after November 10th, because that moved a significant amount of magma through the system. Then after the December 18th eruption, it drops to this point. After the February 8th eruption, it drops to this point. And then here we are up here after this March 16th eruption. I think the best answer I have to answer that would be that as the magma is occupying this space in the subsurface, it is heating up the rocks, it's heating up the crust, and the longer it stays there and the more places it infiltrates, that adds to the thermal buoyancy of the crust in this area. So even though you have eruptions emptying some magma out of the system, that rock is hotter and more buoyant, and so it rises. It occupies more space, more volume. And so that might be one reason why we're seeing, after these eruptive events, a decrease or a deflation that's still quite a bit higher than any of the preceding eruptions. And so the place you can find these things apparently was right there under my nose the whole time. But if you go to the site Vafri that we've been using for our earthquake data, you can come up here to GPS stations and you can select one. So let's maybe select Eldvarp right here. And then that brings up a 90-day plot, which is the main types of plot we've been looking at. So there's the three graphs, north-south, east-west, up-down motion. But then if you keep scrolling down, there's a plot for the whole year. So there's north-south motion for the year at this station, east-west motion, and then up-down motion for Eldvarp for the entire year. So you can see it. You pick out those individual events. And this one nicely shows the November 10th, December 18th, January 14th, February 8th. Here's a little hiccup here from the March 2nd intrusion, and then the March 16th eruption, the one that's still going on here. So that one nicely shows all the trends there. So hopefully some of these answers and some of this discussion is helpful to you. And I'm providing a little bit of insight that is giving you a little more knowledge as I'm learning with you as well. And I did have another viewer. I forgot to write down their name. I apologize. But they sent me this site, or I guess it's the same site, but a different window or whatnot. And this is pretty cool because this actually shows you those GPS stations over time. So you can see we're back here at 2017, January 1st. Now, there's not a way, at least I haven't figured out how to just play it and let it run. I'm sure you could. There's someone that can figure that out that's smarter than me. But you can just sort of move the scroll, the little bar along. And notice here, 2019, nothing. I mean, the Reykjanes Peninsula, just no significant ground deformation motion. As we get into the end of 2020, though, that's when we start seeing a few of these things starting to move a little bit. And I think you can change the scale on this too. So you can make things look bigger. You can exaggerate the scale. I'll just leave it at 1. So you can change the scale. Haven't played with that much. But anyway, so the point I'm trying to make here is you can move this forward and watch as we get into 2021. So at this point we have the Fagradalsfjall area erupting. But still not a lot of significant ground deformation motion, but there is some. And then this thing goes pretty crazy as we get into this latest phase. So here's 2023. I'm trying to drag this slowly. Here we are in June, a little bit of motion. Here we are in September of 2023. Here we are at the end of October. and then boom, things there's the difference that November 10th intrusion, and there's one. It looks like there's one a week if you look at the dates there. So here's November 7th, and then here's a week later, November 18th, and you can really see the components of motion and more or less where that magma dike intruded and really pushed the ground to the southeast, away into the southeast, and the ground to the northwest of that dike was pushed further to the northwest as magma was injected and actually forced its way into those spaces, generating those earthquakes that evacuated the town. And then if we roll forward a little bit since then, and these are vectors, so these are scaled. So the more movement of the station over the past week, the longer the arrow. So not only is the direction important, but the length of the arrow is important as well. And then if we go to, this is into December of this past year, and then January, and then you can see this kind of just continuing all the way up until this latest run here on April 5th. So just really jumps out at you, just the amount of movement there. So, and you can change the scale on these if you want. If those are too obnoxious for you, you can make them smaller. You could also investigate. I haven't taken the time to look at other areas like Askja over here, but I think this is the dominant trend and the thing that jumps out the most. So I'll make sure I put a link to that in the video description as well for those that might be interested. If we just look at earthquakes, there's just not much going on. So earthquake activity over the last 24 or so hours, I'd say all quiet on the western front here on the Reykjanes. Nothing for the most part around the eruption area. A few little tiny quakes over here towards Fagradalsfjall. And then looking at the rest of the country, just nothing of significance, right? A couple small ones here around Askja. I haven't had time to circle back and give you another little, educate myself and share with you some more information on Askja. I haven't had time to read some of those papers like I wanted to. So there's 2.1 deep, not a big deal. So there's the earthquake data. And to round out this update then, just a couple things in the news. And thanks again to Amanda Jo for sending these on. So this one's interesting here. This is an interview and some questions they posed to Magnus Tumi Gudmundsson, who's a geophysics professor in Iceland. And some of the interesting things I found him saying here kind of come at the end. So he talks about some of the data, but he talks about different scenarios that might play out if this were to continue. So he talks about what if this thing goes on, what exactly would happen. And let me find that exact quote there. So what happens if this goes on much longer? Magnus presents several scenarios. The lava could, for example, pile up, move in a continuous flow along the dikes or the defensive berms they've built, and could even end up in the sea. Another scenario is that it goes over the ramparts, so over those defensive berms they've constructed. And then the third scenario would be that the lava builds up a lot and moves in a northerly direction. And so that's an interesting to think about, is that we could have because so much of that lava is spilling out to the south and building up the topography there, depending on how this goes, even though the regional slope is to the south, you could have enough of a topographic obstacle from that lava that's been spilling out for 3 weeks that some of that lava that comes out in the future, if this continues, might get rerouted and start flowing a little bit to the north. Now, I don't think it's going to head all the way down the north slope and end up impacting the coastline over here by the airport and some of these towns, but you could get some of it moving in that direction. So we'll just need to wait and see. What we really need is that, and it's probably hard to do because the eruption's still going on, but if at some point things slow down enough, it'd be great to get a new topographic map over the area to see how much these lavas over the last 3 weeks have changed the topography. Like, for example, we know that the lava flow in, let me pull up my little Google Earth here, that'll be a little bit helpful. We know that the lava flow into this quarry here is like upwards of 15 meters, maybe almost 50 feet thick, and so that's piled up quite a bit there. And so this last little vent that's popped up here, it's changed the topography here quite a bit. And I'm sure when we get when the when this eruption's more or less over, we should get hopefully a new flow field map. And it'd be nice to also have some 3D data on that as well. So not just the extent of the lava field, but how much it's built up the topography, and that might give us some indication where it might go in the future. But if it can't flow to the south any further in the next few weeks to come, if this perched lava channel and the lava pond that was here, if this just becomes an obstacle, remember it has to squeeze between these two high topographic features, this older shield volcano and Hagafelt here. So if it builds up this land in between these two, that would mean that it possibly starts filling in this area between Silingerfelt and Stora Stogafelt. Maybe it starts covering some of these older flows from the December and February eruptions. So it actually starts moving out over this area and maybe out to the east. East would be a great place for it to go because this is just a dead end. This isn't going to impact any sort of infrastructure over here. And obviously what we don't want to see is we don't want to see it moving directly to the west and really testing these defensive berms that have been built around the power plant and the Blue Lagoon. So just some thoughts there. We'll have to see how long this goes on and if that holds up. And then my last thing here for this update before I sign off is that the Blue Lagoon has been reopened. This is as of today. This is quite a controversial decision in Iceland especially. I'm not going to take any sides here because I really do see it from both sides. So even though this is happening literally a few kilometers away from the Blue Lagoon facility, they, in consultation with the authorities, I think they let them decide what they wanted to do as a business, what was best for them. And they were allowed to reopen with some conditions. And yeah, interesting. There's definitely concerns, obviously, with the gas emissions and if the wind were to change. There was already some workers there that I think got sick from breathing in too much of the sulfur dioxide. So it's definitely a controversial decision, and I'll just kind of leave it at that without speculating any further. But we'll go ahead and sign off as we look at this last erupting cone. Who knows how long it'll continue? You can see some of the gases actually escaping from the bridge or the southwest wall here above the lava channel. So again, that just illustrates to you how permeable this accumulated lava spatter is, this agglutinate, that it's not a very dense type of rock. It's just blobs and clots of lava stacked on each other, and that's why we have this channel that's coming out the base here. In order for this thing to break down, you'd have to have you'd have to really thermally erode and widen this out, or possibly have an increase in the lava output to break this down. But my guess would be that it continues to build up that rim of the cone. You can see there's occasionally eruptions that are throwing that lava spatter, especially onto this western, southwestern, and southern sides. Back over here on this side, it's a little bit taller. But we'll see what happens moving forward. Thanks again for joining me, team. I will try to get another one out to you soon, but I do have a very busy week. I have a presentation down in Utah on Monday for the Utah Geological Association. I'm going to try to get a copy of that and share that with you. And then I have a field trip on Thursday in the afternoon. In evening, my Iceland class, the class I'm taking to Iceland, their class meets Wednesday evenings. And then on Friday and Saturday, some of you will be with me because I have my field trips here around Twin Falls on the 12th and 13th to some fantastic geologic sites. And the good news for those folks coming with me on those field trips is the weather looks great. It snowed last night. It was snowy and chilly this morning. It's kind of clearing up now, but the forecast looks great. Highs around 70 Fahrenheit here. If you still want to join us for those field trips, there is still space. So please email me or get in touch with me or Amanda Joe and let me know. And there's still time for you to get signed up if you can be here in Twin Falls on Thursday or Friday. But otherwise, we'll catch you next time. Thanks again for joining me. Appreciate all your support for the channel. Hopefully this was helpful, and we'll continue to monitor this fascinating development and this ongoing eruption in Iceland. Thanks so much.